In this video, we're going to work on understanding the units in an integration problem. Here's a good problem for us to consider. The rate of change of the number of mosquitoes on tropical island at time t days is modeled by this function, which is a rate function. We can tell from the units that are given here, mosquitoes per day. There are 1,000 mosquitoes on tropical island at time t equals 0. Our task is to find the number of mosquitoes on the island at time t equals 14 days. There are some students who might decide to take the 1,000 mosquitoes and add r of 14. Now that doesn't make any sense because remember this is a rate function and it's measured in mosquitoes per day. You certainly can't combine these two terms because they have different units. Those are not like terms. What should happen is we start off with our 1,000 and then we add the integral from 0 to 14 of r of t dt. Now let's check our units again. This 1,000 here is mosquitoes, plus over here, remember r is mosquitoes per day, and then times, don't forget that this differential carries units as well. The time element is also measured in days. And so these days will divide out and we'll have mosquitoes plus mosquitoes will give us our total number of mosquitoes. We hope that it's not too many. Okay, here's another example. This time where we have two rates being given to us. The rate at which the tide removes sand from a beach, as well as the rate at which sand is added to the beach by a pumping station. Our task here is to find the amount of sand on the beach after 6 hours. So, I'm going to start off with 2,500, and then I'm going to add the integral from 0 to 6 of s of t minus r of t times dt. You should stop the video now and see if you can add in the units in the appropriate place. Okay, I'm hoping that you pause the video and that you put down the units that you think are correct. Now let's look at it together and determine where the proper units go. This 2,500 is 2,500 cubic yards of sand, cubic yards. Plus, over here, this s of t is measured in cubic yards per hour. So I'm going to put cubic yards per hour minus r of t is also measured in cubic yards per hour. And then we have to multiply that by our differential, which is measured in hours. Notice here you have like terms which you'll be able to combine into a single unit of cubic yards per hour. So we have cubic yards plus cubic yards per hour times hours here. Notice that these hours divide out and we have cubic yards plus cubic yards will yield an answer that's measured in cubic yards. It's good to analyze the units in any mathematical problem to see if you're on the right track. Thanks for listening and enjoy calculus.